Hello dear students, welcome back to my video. Now I am going to discuss a new chapter 7 from the textbook ncert of class 11, and the chapter is Permutation and Combination. In this chapter, we are going to discuss new technique called permutation and combination. This technique is useful in determining the number of different ways of arranging and selecting objects without actually listing them. As a first step, we shall examine a principle which is most fundamental to the learning of this technique. That principle is fundamental principle of counting. Fundamental principle of counting. Okay, first we can discuss fundamental principle of counting before the discussion of permutation and combination. For the discussion of this fundamental principle of counting, let us consider a problem. In that problem, Mohan has 3 pants and 2 shirts. How many different pair of pants and shirt can he dress up with? We can discuss this problem and understand the fundamental principle of counting. For this, we can name 3 pants as P1, P2 and P3 respectively, and 2 shirts as S1 and S2. Then these 6 possibility can be illustrated as, here we will get 6 possibility of pairing the dress. That is, we have 3 pant and 2 shirt. So 3 into 2 equal to 6. We have 6 possibility for pairing a dress. We can illustrate it as shown in figure. We can take 3 pants P1, P2, P3, and 1 pant can be paired with 2 shirt. There are 2 shirt S1 and S2. Therefore P1 S1, P1 S2. Similarly, second pan can be paired with 2 shirt P2 S1, P2 S2, and third pan can be paired with 2 shirt P3 S1 and P3 S2. That is, there are 6 possibilities for pairing the dress. Let us consider another problem of same type. That is, Shabnam has 2 school bags, 3 tiffin box and 2 water bottle. In how many ways can she carry these items? That is, we have to show the pair she is taking these items to the school in each day. How many pair can she done using these items? Okay, let us consider 2 bags as B1 and B2, then 3 tiffin box as T1, T2, T3, and 2 water bottle as W1 and W2. Okay, then we can show the each pair. Here we can illustrate each pair by using this figure. That is, we have 2 bags B1 and B2. It can be paired with 3 tiffin boxes T1, T2, T3, and also it can be paired with 2 water bottle W1 and W2. Then we get each pair as, first one B1, T1, W1, second B1, T1, W2. then B1 T2 W1, B1 T2 W2, then B1 T3 W1, B1 T3 W2. Then for second bag, B2 T1 W1, B2 T1 W2, B2 T2 W1, B2 T2 W2, B2 T3 W1, B2 T3 and W2. These 12 are the possible pairs she can carry. In fact, the problem of above types are solved by applying the principle known as fundamental principle of counting, or simply the multiplication principle. We can call this principle as multiplication principle. Multiplication principle. The fundamental principle of counting states that if an event occurs in m different ways, following which another event can occur in n different ways, then the total number of occurrence of event in the given order is m into n. That we seen in first example, that Mohan has 3 pan and 2 shirt. The total number of event is 3 into 2, which is equal to 6. That's the theorem said here. If an event occurs in m different ways, that is 3, which following which another event can occur in n different ways, that is 2 shirt, then the total number of occurrence of event in the given order is m into n, that is 3 into 2 equal to 6. Total we get 6 pair of shirt and pants in first example. Similarly, this principle can be generalized for any finite number of events. For example, for 3 events, that is if an event occurs in m different ways, following which another event can occur in n different ways, following which a third event can occur in p different ways, then total number of occurrence to the event in the given order is m into n into p. That is, we can add any event and the answer is multiply each events. That is, we seen in example 2. That is, Shabnam has 2 bags, 3 tiffin and 2 water bottle. There m equal to 2, n equal to 3 and p equal to 2. That is, we got total 12 pairs. Let us discuss one example. Find the number of 4-letter words with or without meaning which can be formed out of the letters of word ROSC where the repetition of letter is not allowed. Solution. There are many words as there are way of filling in 4 vacant places by the 4 letters. That is, we can fill in 4 vacant places because there is 4 letters. Okay. First place can be filled in 4 different ways by any one of the 4 letter ROSC. We can fill this first place by any one of the letter ROSC. Then the second place can be filled by any one of the remaining 3 letters in 3 different ways. Following which the third place can be filled in 2 different ways. following which the fourth place can be filled in one way. The number of ways in which the fourth place can be filled by the multiplication principle is 4 into 3 into 2 into 1, which is equal to 24. Hence the required number of word is 24. In this example, we are actually counting the different possible arrangement of letter such as ROSE, REOS, RSOE, etc. Each arrangement is different from others. Each arrangement is called a permutation of 4 different letters taken at a time. That is, we can define permutation by using this example. That is, permutation is the arrangement of each word. That is, in previous example, we arranged 4 different letters taken all at a time. Therefore, we can say each arrangement is called permutation of 4 different letters taken all at a time. Okay, permutation have many definition. The definition 1 is a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. We can consider permutation in two different cases. That is, when all objects are distinct, and the permutation when all objects are not distinct. Then we have to prove some theorem also. We can discuss one by one. First case, permutation when all objects are distinct. It is discussed by theorem. Theorem 1. The number of permutation of n different objects are taken r at a time where 0 less than r less than or equal to n and the object do not repeat is n into n minus 1 into n minus 2 into etc. into n minus r plus 1, which is denoted by NPR. That is, theorem says that number of permutation of n different objects are taken r at a time. Then we can define permutation NPR equal to n into n minus 1 into n minus 2 into etc. into n minus r plus 1. This is the theorem 1. Next, we can prove the theorem. Hence, we can prove the theorem. Like other chapter, this proof is not a problematic way. This proof consists of some theoretical part. We have to write some sentences to prove this theorem. Okay, let's start. There will be as many permutation as there are ways of filling in r vacant places. That is, we can fill r vacant places, etc. by the n objects. The first place can be filled in n ways. The second place can be filled in n minus 1 ways. Following the third place can be filled in n minus 2 ways. And rth place can be filled in n minus r minus 1 ways. That we wrote here. First place can be filled in n ways. Second place can be filled in n minus 1 ways. Third place can be filled in n minus 2 ways, etc. The rth place can be filled in n minus of r minus 1 ways. Therefore, number of ways filling r vacant place in the succession is n into n minus 1 into n minus 2 into etc. into n minus r minus 1. Or we can write n into n minus 1 into n minus 2 into etc. into n minus r plus 1. This expression for NPR is cumbersome and we need a notation which will help to reduce the size of this expression. The symbol n factorial, we read it as n factorial, comes to our rescue. In the following text, we will learn what actually n factorial means. Here we prove the theorem, that is np are equal to n into n minus 1 into n minus 2 into etc. into n minus r plus 1. And this expression is cumbersome, so we need a notation that we use n factorial, that we will discuss in next part. Let's discuss factorial notation. The notation n factorial represent the product of first n natural number. This represent product of n natural number, that is n factor equal to 1 into 2 into 3 into etc. into n minus 1 into n. Similarly, we can write 1 factor equal to 1, 2 factor equal to 1 into 2, 3 factorial equal to 1 into 2 into 3, 4 factorial equal to 1 into 2 into 3 into 4. Similarly, we define 0 factorial equal to 1. Also, we can write 5 factor equal to 5 into 4 factorial, which is equal to 5 into 4 into 3 factorial, which is equal to 5 into 4 into 3 into 2 factorial, which is equal to 5 into 4 into 3 into 2 into 1 factorial, which is equal to 5 factorial. Clearly, we can write n factor equal to n into n minus 1 factorial, which is equal to n into n minus 1 into n minus 2 factorial, which is equal to n into n minus 1 into n minus 2 into n minus 3 factorial, and so on. Let's discuss some problem. Evaluate 5 factorial, 7 factorial, 7 factorial minus 5 factorial. Solution: 5 factor equal to 1 into 2 into 3 into 4 into 5, which is equal to 120. 7 factor equal to 1 into 2 into 3 into 4 into 5 into 6 into 7, which is equal to 5040. Therefore, 7 factorial minus 5 factor equal to 5040 minus 120, which is equal to 4920. Next, evaluate n factorial by r factorial into n minus r factorial when n equal to 5 and r equal to 2. Therefore, we can write 5 factorial divided by 2 factorial into 5 minus 2 factorial, which is equal to 5 factorial divided by 2 factorial into 3 factorial, which can be evaluated by 5 into 4 into 3 factorial divided by 1 into 2 into 3 factorial. 3 factorial get cancelled. You can write 5 into 4, 20 divided by 2, which is equal to 10.